Okay, this is the problem where we left off on the first day of notes on circles from chapter 12. So I realized after I finished the last recording that you may have thought to solve this quadratic a different way on the last problem from the notes last time. So if you subtracted the 49 on both sides, you'd have x squared minus 25 equal to 0. And then you could factor it like x minus 5 and x plus 5 equal to 0. And remember, you said each of those factors equal to 0. That'd give you x equals 5. And that one would give you x equals negative 5. I think that might be simpler rather than having to square root, because when you square root, you have to remember that you get two answers. So you do a lot more quadratics in Algebra 2, and maybe after doing that, it would be more natural. But it just occurred to me that might be simpler for you. Okay, so we're going to pick up here with the next theorem. The theorem says in the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So that means in this picture, arc AB being congruent to arc BC or CB, okay, means that these chords are congruent. Remember, the chords are segments. Now, they don't have to be touching like they are in this circle. So on this circle, the arcs are touching and the chords are touching. That doesn't have to be the case. Okay, but this says arc AB is congruent to arc BC if and only if chord AB is congruent to chord BC. So on this problem, we're given that the two chords are congruent. So that chord and that chord are congruent. And that means that the arcs are also congruent. Congruent chords cut off congruent arcs. And that means that the measure of arc AB would also be 108 degrees. Okay, the next theorem says in the same circle or congruent circles, two chords are congruent if and only if they're equidistant from the center. So if these segments are congruent, then that means these segments are congruent and vice versa. Okay, so segment AB is congruent to segment CD if and only. Okay, so in the next problem, we have that circle J is congruent to circle K, and arc MN and arc PQ are congruent. That means that our chords here will also be congruent. So 2x plus 1 is equal to 3x minus 7, and that is because in congruent circles, congruent arcs cut off congruent chords. X equals 8, and then we're looking for PQ, so PQ is going to be 3 times 8 minus 7, which is 17. Okay, next problem. The circles on this one were always also given to be congruent. I want you to notice that 360 minus 155 would be 205 degrees. So that means that on this circle, that's 205. And on this circle, that arc would be 155 degrees. And that means that, again, notice where the chord is. It's on the 155-degree side of the center. And same thing on this one. The 3x is on the 155 side of the center in its circle. So that means that these chords will be congruent because these arcs are congruent here and here. Okay, so since the arcs are congruent, that makes the chords congruent to each other. And that is going to cause 3x to be equal to 7x minus 44. And so 4x equals 44, x equals 11. Segment EF is congruent to segment EG. Okay, so in this diagram, these chords are congruent if and only if, remember it goes both directions, if and only if the segments here are the same. Okay, so if these chords are congruent, then the little segments there are the same. I want to remind you that the way you find distance between a line and a point is the perpendicular distance. So you don't go like at any particular angle like that. What you want to do is find the perpendicular distance because that's the shortest distance, okay, between a point and a line. So if you're looking for the distance between the center E and this chord, you have to consider that to be the perpendicular segment there. And that's why it says in the problem about being equidistant. They're talking about the same distance. Okay, so here we have a circle. In circle H, PQ is 3x minus 4 and RS is 14. Because these segments are the same length in a circle, chords equidistant from the center are congruent. So that means that 3x minus 4 will equal 14. 3x is 28. Oh, sorry, 18. X is 6. It just asked us to find x, so we have done that. Okay, next problem. In circle A, segment WX and segment XY are both 22. Those are chords, right? Those two segments are both 22. That means that these little segments will also be congruent. So in a circle, congruent chords are equidistant from the center. Of the circle. Okay, so 5x is equal to 3x plus 4. So 2x is 4, x is 2. Now it asked us to find AB. AB is 5x, so 5 times 2. AB is 10. Okay, next theorem. In a circle, diameter is perpendicular to a chord if and only if it bisects the chord and bisects the arc. Okay, so in this circle, if that's a right angle, okay, so we're looking at this diameter and that chord. Okay, a diameter is perpendicular to a chord if and only if a chord here that's being bisected, and we also should have an arc that's being bisected. So that would be this arc right here is being cut into two congruent arcs. Let's call that circle O like it is in the other picture. So if segment OG is perpendicular to segment DF, if and only if segment CE is congruent to segment DE and arc CA is congruent to arc DA. My letters here and here don't quite match, but I think you get the idea. Okay, so we have measure of arc PQR is 98. Now, because this is a right angle, that means that that arc is being bisected. So the measure of arc PQ is going to be just half of 198, so 49 degrees. Okay, now some of the more challenging problems that you'll see in this lesson are going to be when you see pictures like this. So first of all, we're given some information and we're asked to find the length of segment TV. So we're looking for this whole segment. What I want you to focus on is the smaller segment here. Okay, so the smaller segment, if we double that, that will be TV. Now, the reason I want you to look at that is because we can draw in a triangle that would be helpful to figure out what's going on. So because the right angle there, that right angle tells you that segment TV is bisected, it's cut in half. Okay, so we're going to draw in a triangle. And sometimes students think they should draw the triangle over here. The reason that that's not going to be helpful is because we don't know that segment we just drew, and we also don't know the highlighted segment. So we would have two unknown lengths there. Now, notice that we do actually know the radius of the circle. The radius is 11 because it's this whole segment and it's 5 plus 6. So they've kind of indirectly given us the radius. So what I'm going to do is I'm going to draw a triangle like this. And notice that that is a radius, so I know that that's 11. Okay, and we're going to figure out what that segment right there is. So I'll do x squared plus 6 squared is 11 squared. That's 36 and 121. X squared is 85. So x is the square root of 85. Now, it's around the nearest hundredth, so that's approximately 9.22, and that means that TV is double that, which is 18.44, and that's just in units. I would like you to add on a problem to these notes because sometimes you'll also see circle problems that have right angles in them like that, and you actually need to draw right triangles in these also. This one is different than the last one because you weren't given this little segment that I'm calling X over here. You were instead given that little piece. So we're going to again draw in a right triangle. Notice that we were given that their radius is 10. So this time we can go ahead and draw in a right triangle like that again, and the radius will be 10. Now this time we know that because of the right angle there, those two segments are congruent, so we actually have that side. So the way we're going to find X is we're going to figure out this other little piece here, this other little piece right there, I'm going to call Y. And then once we know Y, we can just subtract it from 10. So since this is a radius over here, this whole thing there is a radius, we'll be able to say 10 minus Y to give us our X value. Okay, so it all starts with figuring out what you know and where it's helpful to draw in the right triangle. So this one would be y squared plus 8 squared equals 10 squared. Or if you recognize that as a 6, 8, 10 right triangle, you can kind of skip that step a little bit. Okay, so that is y squared would be 100 minus 64, so 36. Y is 6. We're only keeping the positive value. Okay, so if y is 6, that's that little part right there is 6. That means that x has to be 4 because the whole radius is 10. We're going to take off that 6, and x would be 4. Okay, so those two problems are both involving drawing in right triangles. And it's helpful to do that, again, because we know their radius, and we know we have right triangles. All right, find the value of y. So for this one, because we know that we have congruent pieces of the chord there, since the chord is bisected, that means that's a right angle. Okay, right angle because chord bisected. Okay, so notice that the 15 that's given there is actually our radius. So that means that that segment over there is also 15. This time they've drawn in the triangle for you to help you focus on what is actually happening there. Okay, so that means that we have a right triangle, so we can do y squared plus 11 squared is 15 squared. Y squared plus 121 equals 225. Y squared would be 104, and that means y is the square root of 104. That breaks down, 4 divides out of that 26 times. So that means that y is 2 root 26. I didn't ask you to round this time. That means you should leave your answer exact and simplified. All right, next problem. Circles A and B are congruent. Segment CD is a chord of both circles. AB is 8, CD is 6. We want to know how long their radius would be. Okay, so these are perpendicular and they're also bisecting each other. So that means that this length here is going to be half of the 8, so it's 4. And this length here is going to be half of the 6, so it's 3. And so I'm going to draw in a radius there to make a right triangle. And it's asking you what a radius, how long the radius is. So that's what we're actually looking for. Okay, so that's a 3, 4, 5 right triangle. Or if you do the Pythagorean theorem, x squared is equal to 4 squared plus 3 squared. X squared would be 16 and 9 is 25. X would be 5, and that's the radius. Okay, next theorem. I know this is kind of long. There's 2 more theorems, and I believe we're done. Okay, so this is actually one that's really helpful to know. So first of all, the definition, if you don't remember what inscribed and circumscribed means, if a polygon's vertices lie on the circle, so if you have a circle, okay, and there's a polygon where all of the, make this a little bit smaller here, all of the sides, all the vertices of the polygon are on the circle. Okay, so those points are on the circle. Then we say the polygon is inscribed in the circle, and we say the circle is circumscribed around the polygon. Okay, so something that's helpful to know about circles and right triangles. If a right triangle is inscribed in a circle, so that means if you have a right triangle where the vertices are all on the circle, then that forces that to be a right angle, and the hypotenuse will actually be a diameter. Okay, the hypotenuse will be a diameter. So if a right triangle is inscribed in a circle, its hypotenuse is a diameter of the circle. And if a triangle is inscribed in a semicircle, then it'll be a right triangle. So notice that basically that's saying that if you have any right triangle that's inscribed in a circle, so let's say I draw another one here. If I have a right triangle that's inscribed in a circle, if I know that's a right angle, when I finish off the rest of that right triangle, that has to be a hypotenuse. Okay, that means it's going to go through, that has to be a diameter. It's going to go through the center of the circle. So anytime you see a triangle inscribed in a semicircle, it's always going to be a right triangle. That means it fits in half the circle, so it's got to be a right triangle. Okay, so example. When you're looking at this picture, what you want to notice is that little segment right there is going through the center of the circle. And since it's a diameter, that means that this is going to be a right triangle. Oops, sorry about that. Okay, what you want to notice is that on this problem. The triangle is actually inscribed in the semicircle because that's a diameter. That means it's going to be a hypotenuse, and this will be a right triangle. So since it's a right triangle, that means that x and x plus 12 are going to add to 90. 2x is 78, x be 39. Okay, and then the measure of angle W is just 12 more than that, so that makes that 51 degrees. Remember that the angles in a right triangle that are acute will be complementary. You could also have added all of them up to 180 if you want. I just took off the 90 to begin with. Okay, this problem would be the same exact thing. I'm just going to skip that one because it's the same exact kind of problem. Okay, and then lastly, problem involving quadrilaterals. A quadrilateral that's inscribed in a circle has opposite angles that are supplementary. Okay, it's opposite angles and they are supplementary. It's opposite angles and they are supplementary. Now, the reason I said that a bunch of times is because what happens is students try to make them congruent and not supplementary, and then they get the problems wrong. Okay, so those two are supplementary, and then same thing for the other ones. So the measure of angle B plus the measure of angle D should equal 180, and the measure of angle A and the measure of angle C should equal 180. Okay, they're supplementary. They're not congruent. They're supplementary. It's opposite angles. Okay, so that's what's happening down here. You can just say, all right, since that's an inscribed quadrilateral, it's four-sided polygon that where all the vertices are on the circle, that means that we know that 2x and 100 have to add to 180, or 2x has to be 80. If you want to go straight to that step, you can. And then x is 40. And then even easier, y plus 87 has to equal 180. That'll make y equal to 93. Okay, it'd be the same kind of problem over here. You're just going to make those supplementary. So you have y's adding up to 180. And then for the other ones, you'd have x's adding up to 180. So I'm going to skip that one because, again, this is kind of a long lesson, and that one's the same idea as the previous one. What's different in the next problem is that we have an inscribed quadrilateral. However, the opposite angles have different variables on them. Okay, so you want to make sure you don't assume that the consecutive ones are congruent or supplementary or anything, because we don't know anything about the consecutive angles. What we know is that if a quadrilateral is inscribed in a circle, quadrilateral inscribed in circle makes opposite angles supplementary. Okay, so we're going to have 29y plus 8x is equal to 180. And we're going to have 21y plus 12x equals 180. Okay, opposite angles are supplementary. Opposite angles are supplementary. Okay, now I'm noticing that I can divide out a 3. So I'm going to take a 3 out of the bottom one because that'll make my numbers a lot nicer. So if I divide out a 3 there, okay, that's going to give me 7y plus 4x equals 60. I don't know why I put y first. It really doesn't matter. You could put x first, but it's just what I saw. Okay, and then we're trying to do elimination here. It's usually easier than substitution. So I'm noticing that my X's would be easy to eliminate. So I'm going to go ahead and multiply the bottom equation here, my second equation, by -2. Because again, what I'm trying to do is make my coefficients opposites so that I can do elimination. Let's go ahead and copy this down here. 29y plus 8x equals 180. And then if I put that one down below it, I have -14y minus 8x is equal to -120. Then when I add them together, that'll make the x's drop out. Remember, this is called elimination. Okay, so we have 15y is equal to 60, and then y is 4. Now that's one of the variables. It asked us to solve for x and y and also find the angle measures. Okay, so I know that y is 4. That means that up here I can do 29 times 4 and get that that angle measures 116. Okay, so there's one answer. So if that's 116, that means that this opposite angle here has to equal 180 minus 116 because they're supplementary. So that's 64, and that means that x is 8. So that was one of the things we needed was the value of the variable and then also the angle measure. Now we can just plug in. So on this one, we get 12 times 8 is 96. And then on this one, we'd have 21 times 4, which is 84. And then also those should be supplementary. So we can kind of double check that those two are also supplementary. Okay, that's the end of this lesson.